thought prompting enhances understanding by exposing the reasoning process behind answers, rather than merely providing solutions. This method plays a crucial role in complex problem solving. For instance, planning a birthday party serves as an illustrative example of how standard prompting contrasts with chain of thought prompting. This comparison highlights the latter's effectiveness in clarifying reasoning, making it particularly useful for addressing tricky questions. In discussions of AI, transformers are often likened to the brain, showcasing their unique capability to process multiple pieces of information simultaneously. Nevertheless, they also encounter inherent limitations in their design. Importantly, chain of thought prompting allows AI to circumvent limitations in sequential tasks, akin to following a blueprint for complex problem solving. This structured approach significantly enhances the efficiency of the process. The inherent capability of transformers to function as general-purpose computers suggests applicability across various fields, ranging from mathematics to intricate decision-making tasks. This versatility is crucial for advancing AI. Intermediate reasoning tokens play a vital role in the problem-solving process, as they enable transformers to build understanding iteratively rather than jumping to conclusions, ensuring a deeper grasp of issues. Moreover, the chain of thought technique facilitates the dynamic construction of reasoning paths. This adaptability allows models to approach a variety of problems without relying on predefined structures, thereby enhancing problem-solving efficiency. Generating intermediate tokens enables models to articulate their thought processes step by step. This method not only avoids hasty conclusions, but also enhances clarity and overall understanding of the reasoning involved. A consistent depth in neural networks suggests that increasing the number of layers isn't always necessary for improving problem-solving capabilities. Instead, focusing on intermediate reasoning can preserve or even enhance performance. Circuit complexity illustrates how enhanced transformers can solve a broader range of problems, significantly expanding their computational capabilities. This advancement encompasses both parallel and serial problem solving. The introduction of the chain of thought mechanism allows transformers to simulate complex computations, signifying that they can theoretically perform any computation achievable by a Boolean circuit. While findings indicate remarkable flexibility within transformers, they do not suggest that these models embody artificial general intelligence. This distinction emphasizes the difference between theoretical capabilities and practical AGI. The concept of computational universality within transformers parallels that of a Turing machine, demonstrating their ability to execute any computation without possessing human-like awareness. This underscores their limitations in reasoning capabilities. Integrating cognitive abilities such as learning, perception, and reasoning presents critical challenges for achieving AGI. Current transformers, despite advancements, still face difficulties in exhibiting these capabilities consistently. Employing the chain of thought approach enables transformers to address complex problems more effectively, uncovering their potential beyond earlier assumptions. Nevertheless, their success heavily relies on proper guidance and structured prompting. The chain of thought technique demonstrates that transformers can adeptly manage both parallel and sequential problems, significantly enhancing their problem-solving versatility. This dual capability marks a considerable leap in AI technology. Recent research by OpenAI aligns with the chain of thought concept, revealing that teaching AI to reason through problems step by step results in superior performance. This methodology emphasizes the importance of quality over quantity in AI training. Ultimately, the shift in AI development now prioritizes enhancing reasoning skills rather than merely increasing model size. This focuses on creating more efficient and powerful AI systems capable of critical thinking, akin to human cognition.